Question 3, z to the 5 is equal to 1. Need to determine the complex fifth roots of unity. The first root is 1. Other roots will just be the Argand diagram equally divided. So if we have a quick look at the Argand diagram and quickly divide it, the first root here is 1. So the following roots will be that z2 is equal to cos I sine of 2 pi on 5. z3 will be cos I sine of 4 pi on 5. z4 cos I sine, there'll be one round here, negative 2 pi on 5. And z5 cos I sine, coming around this way, negative 4 pi on 5 are the 5 roots of unity. So hence, if I want to factorise z to the 5 minus 1 over the complex field, then these are my roots, and so the factors must be z minus 1, z minus cos I sine 2 pi on 5. Not enough room here. Z minus cos I sine 4 pi on 5. Z minus cos I sine negative 2 pi on 5. And the final one is Z minus cos I sine negative 4 pi on 5. So that's the factorisation over the complex field. Taking it further to the real numbers, I'll need to obviously keep in my z minus 1 because that is over the real field. Then I'll pair these up and I'll look at it and I've got z minus cos I sine 2 pi on 5. And I've got z minus cos I sine negative 2 pi on 5. I'll pair those ones together and I'll do the same with the cos I sine 4 pi on 5 and z minus cos I sine negative 4 pi on 5. Okay. Now this is going to get a little bit long, I probably won't fit it in here, but I'll keep working. So I can say that's z minus 1, these ones here. This one I can write as z minus cos of 2 pi on 5 minus I sine 2 pi on 5. And this one here, definitely don't have enough room here, z minus cos of negative 2 pi on 5. We know cos of negative is the same as cos of positive. Sine of negative, however, is negative the sine of the positive value, and negative make that plus I sine 2 pi on 5. And that's multiplied by the 2 with 4 pi on 5 of them, z minus cos of 4 pi on 5 minus I sine 4 pi on 5, which is this one expanded out, times by z minus the cos of 4 pi on 5 plus I sine 4 pi on 5, which is this one up here expanded out. Okay, continuing on, having rewritten it a little bit more user friendly, but it's a very long expansion. Okay, so the z minus 1 is still staying there as one of the factors over the real field. If I have a look at these two factors, and I'll just do these two and you can apply exactly the same to these ones down here. What I actually have is a difference of squares where this is one term and then minus I sine 2 pi on 5 plus I sine 2 pi on 5. So when I multiply these two together, I get z minus cos 2 pi on 5 all squared minus I squared sine squared of 2 pi on 5. And so doing the same to these ones here will give you z minus cos of 4 pi on 5 all squared minus I squared sine squared 4 pi on 5. So again, real factor, that one works as a real number. This one here, I squared has become -1. We're going to get rid of the i's, we're going to have left just real numbers, hence it's going to be factorised over the real field. When I expand this, I'm going to get z squared minus 2z cos 2 pi on 5 plus cos squared 2 pi on 5, and a minus makes a plus sine squared 2 pi on 5. And you're going to get the same sort of thing happening in the other bracket. I'll leave you to do that one yourself. So you're going to get z minus 1. This one, if you have a look at it, you've got z squared minus 2z cos 2 pi on 5. All real numbers so far. Cos squared plus sine squared, the identity is simply equal to 1. And so if you did the same over here, you'd get z squared minus 2z cos 4 pi on 5 plus 1, and that's the factorisation over the real field.